In this video, we're talking about how to use squeeze theorem to evaluate a limit. Squeeze theorem is also called sandwich theorem, and the reason it's called squeeze theorem is because we're going to try to squeeze the function we've been given in between two other functions whose limits we already know. So in this case, our problem is going to be pretty easy because we have a trigonometric function as part of our larger function. And when that's the case, squeeze theorem problems are pretty easy because here's what we do. We know that the cosine function oscillates back and forth between y equals -1 and y equals +1. So if you look at a graph of cosine is going to go up and down like a wave back and forth between y equals -1 and +1. It's never going to attain a value smaller than -1 or a value larger than +1. That's what the cosine function does. So what we can say is that cosine, no matter what value here is inside the cosine function, the cosine is always going to be greater than or equal to -1 and at the same time less than or equal to +1. Now notice that we're squeezing the cosine function in between two other values, -1 and +1. Now that by itself is not necessarily helpful. What's helpful is if we can transform this function in the middle into something that matches our original function exactly. And the way that we can do that is by multiplying by x squared. Because if we multiply cosine of 10x by x squared, we're going to get back to our original function. But because we have an inequality here, whenever you multiply one value in an inequality, you have to multiply all of the other values in the inequality by that same multiplier. So what we're going to do is multiply this whole thing, multiply through each term, by x squared. So when we do that, we're going to get on the left-hand side here, -1 times x squared, or -x squared. In the middle, we're going to get x squared cosine of 10x, and on the right hand side we're going to get 1 times x squared, which is x squared. Now we're closer to our original limit problem, but remember the thing we're trying to do is to take the limit of this function as x goes to 0. So what we want to do is take the limit of this middle part here as x goes to 0, but if we're going to take the limit of the middle of the inequality, we also have to take the limit of the left and right hand sides. So we're going to apply limit as x approaches 0 of the left-hand side here, -x squared, less than or equal to the limit as x goes to 0 of the middle, x squared times cosine of 10x, and then we're going to apply the limit to the right-hand side, the limit as x goes to 0 of x squared. Now here's where squeeze theorem really starts to come into effect. We can easily evaluate the limit on the left-hand side of the inequality here. If we plug in x equals 0, what we're going to get here is 0 squared, that's 0. When we multiply by -1 here, this negative sign, we still get 0. So this whole value, the limit as x goes to 0 of -x squared, is 0. So on the left-hand side here, we have 0. Then we have the entire middle of the inequality. And then on the right-hand side, we have another limit that we can easily evaluate. We're taking the limit as x approaches 0 of x squared. Well, if we plug in x equals 0, we're going to get 0 squared, which is just 0. So this limit x goes to 0 of x squared, this whole value just becomes 0. So what we end up with on the right-hand side is 0. And now this is a perfect illustration of squeeze theorem, because what we're basically saying is we have the original limit we were asked to find, limit x to 0 of this function x squared cosine of 10x. We know that that has to be greater than or equal to 0, and at the same time, less than or equal to 0. Well, something, no matter what it is, it can't be greater than 0 and less than 0 at the same time. So really what we're looking at is the fact that it says greater than or equal to and less than or equal to, which means that this whole value has to be equal to 0 because it's squeezed in by zeros on both the left and the right-hand side. If it has to, at the same time, be greater than or equal to 0, and also it must be less than or equal to 0, the only possible value for this limit function in the middle is 0. Therefore, without even evaluating the limit, we can go ahead and say that this limit is equal to 0 because by squeeze theorem, we know that it must at the same time be greater than or equal to 0 and less than or equal to 0, which means the only possible value for the limit function is 0 itself.